All right, welcome students. Today we will discuss distance versus displacement and then speed versus velocity. Let's start with distance. Okay. So distance is just the length between 2 points. So here we have a house and a school, and the length is actually 1600 meters, right? 1600 meters, or that would be called 1.6 kilometers, right? Now let's move on to displacement. Displacement, it can be thought of as an overall change in position. That will be overall change in position or the shortest distance between the starting and end point. Or you can think about displacement as the distance in a given direction. As you can see from here, the image shows that there is a shortest distance here, and this one is the displacement here, right? That's displacement. Then let's look at speed. All right, so speed is just how fast an object travels. Most of the time we talk about average speed. That will be the total distance covered and divided by the time taken. So if you have a point A and B, if you tell me the total distance covered and how long it has taken you to move from A to B, I can tell you the average speed. All right, so example, if you cover like 1600 meters in 10 minutes on your way to school, thinking about a nearby school, about 1 mile, that's 1600 meters, and you take 10 minutes to walk to school, or maybe walking fast to school, then your average speed will be distance covered. So we are going to write distance covered as delta D. So this is delta D over delta T. So this triangle here means delta. It means change in delta or change in distance. So change in distance. So we're going to use this symbol a lot to use it as a shorthand for distance covered or change in distance. So change in distance divided by change in time. Distance has changed like 1600 meters and the time has been 10 minutes. You divide that, you get 160 meters per minute. It might be worthwhile to convert 160 meters per minute. We know that there are 60 seconds in 1 minute. If you divide 160 meters by 60 seconds, you get 2.7 meters per second. That means you cover 2.7 meters every second. That's pretty much walking fast. That's like kind of like a little bit running, yeah. So 2.7 meters per second. All right, so let's look at the concept of instantaneous speed. This one is just the speed at any instant in time, all right? And this is given by your speedometer. And you can think about calculating this quantity by looking at a small change in distance and you divide by small change in time. That will give you the speed at a given instant. That's instantaneous speed. Think about the speedometer. When you think about instantaneous speed, that's the speed you write in your dashboard in your car. All right, now let's move on to velocity. So velocity is just the speed in a given direction. If you tell me how fast I am going, and you tell me the direction I'm heading to, then that's actually velocity, right? So it's a vector quantity. Remember, a vector is a quantity that is fully described by magnitude and direction. So we see here that we need the magnitude, for example, 2 meters per second, and the direction east. Then the whole thing here will be called the velocity. Okay, so you can compute average velocity by looking at the overall displacement divided by the time taken. That's how you compute average velocity. Now let's look at summary kind of. So we have seen that we have looked at distance, speed, displacement, and velocity. So we see that distance and the speed are actually scalar quantities. I can fully describe these quantities by magnitude and magnitude only. I don't need a direction for distance and speed. Once I tell you distance, that's fine. That's fully description of a distance. Speed, I just have to tell you how fast I'm moving. But when it comes to displacement, I need to know distance. I need to know the what, how much I have covered, but also direction. So it's distance in a given direction. That would be a vector quantity. And velocity, I need to know how fast I am moving, but also I need to know in which direction am I heading to. So when I have that question, then I'm talking about a vector quantity. So these quantities vectors are very common in physics. We have to understand how to actually add them or how to subtract them. All right, so let's see how else can we talk about these four quantities. Think about quantity in terms of units. Internationally agreed units of distance are the meters. Internationally agreed units for displacement, meters as well. But for speed and velocity, internationally agreed units, the ones we are going to use a lot in this in our conceptual physics course, the meters per second. So velocity and speed have the same units, although they are different quantities. All right, so that's it. If you have any question, please let me know. I'll stop here for now.